sum number 20th, we have the figure given where AB passes through the center, that means AB is the diameter, and we have to just fill in the blanks of these proof already given. Okay, draw seg OD, this is also given. Okay, so angle ACB equals to dash. By reading the reason, we'll try to write what will be this angle inscribed in a semicircle. You know, any angle which is inscribed in a semicircle is equal to 90 degrees. Correct? So now angle DCB equals to dash. We'll read the reason and then try to answer this. CD is the bisector of angle C. CD is the bisector of angle C. You know angle C is 90 degrees. So DCB will be half of 90 degree. So it will be, of course, 45 degrees. Okay. Now let us come to what is measure arc DB. You know measure arc DB. You know DCB, this was 45 degree. So by inscribed angle theorem, this arc will be twice of 45 degree. So this will be 90 degree by inscribed angle theorem. Now because this arc is 90 degrees, the central angle will also be equal to 90 degree. So angle DOB is also equal to 90 degrees. Okay. Now seg OA is congruent to seg OB. Seg OA is congruent to seg OB. What is the reason? They are radii of same circle. Okay. So if you observe this now, line OD is dash of seg AB. Line OD is dash of seg AB. You know, from this we can call it perpendicular, and OA is congruent to OB. So I can call it perpendicular bisector. Okay. Okay. So with this we finish our 20th one. Let us move on to 21st sum. Coming to sum number 21, we are given this chord Mn, where Mn is 25. You can see L is any point on Mn such that ML is 9. Okay, and OL, O is the center, the distance OL is 5. With the help of this much information, we are asked to find the radius of the circle. So of course we will first draw the radius. Draw ON. Okay, this I'll draw, and also I'll draw one perpendicular. Say this is R I'll take, and I'll write draw OR perpendicular to MN. Okay, now because we have to find ON, OR, okay, so we'll first try to find RN and OR, because once we get this, we can easily find ON by Pythagoras theorem. Okay, so I'll first try to find RN. RN is equal to half of Mn. Why? Because perpendicular drawn, you know, you have studied this last year, perpendicular drawn from the center of the circle to the chord bisects the chord. Okay, so that means it is half of 25. So Rn will be how much? 12.5. Correct. Now we are interested in finding OR. So can we find LR first? Yes. Rm will also be equal to 12.5 because Rn is 12.5. Rm will also be 12.5. So can I find LR? Yes. LR will be how much? LR will be Rm minus Lm. LR will be Rm minus Lm. So it will be 12.5 minus 9. So it is how much? LR is 3.5. Once I got this LR and I have OL, so I can find OR. So in triangle OLR, angle ORL equals to 90 degree. Okay. Now, therefore, OL square is equal to OR square plus RL square. You can write by Pythagoras theorem. OL square I'll write 5 square. OR we are to find. RL is 3.5 square. So OR square is equal to 5 square minus 3.5 square. This 3.5 will move here. This will be 25 minus, what is 35 square? 35 square is 1225. Okay. So OR square will be equal to 12.75. Okay. For the time being we will keep it as it is. We will not make it square root because this will be helpful to us. Now I am taking in triangle ORN. You can see triangle ORN. Angle ORN equals to 90 degree. Therefore, ON square is equal to OR square plus RN square. Okay, ON square is equal to OR square plus RN square. So, ON square is equal to OR square, I am writing here 12.75 plus RN square. RN square, it is 12.5 square. Here you can write Pythagoras theorem. Okay. So 12.75 plus, what is the square of 12.5? Square of 12.5 is 156.25. Okay. And if you add this, you will get 169. So ON you got 13. Okay. So what is the radius of circle? Radius of circle is 13. Okay. Very simple. Okay. Let us move on to the next question. Question 22. Coming to question number 22. We have to prove angle PRQ plus angle PSQ. These two angles are supplementary. Very simple. You can see angle RPQ. Just observe angle RPQ. Angle RPQ will be equal to which angle? Just observe which arc is it intercepting. This arc? Yes or no? Another angle which is intercepting the same arc is RSP. Yes or no? RSP is also intercepting the same arc. So I am writing it is equal to RSP. Another one will take RQP. Come on. You try to answer this. RQP. Angle RQP will be equal to RSQ. Okay, RQP will be equal to RSQ. They both have a same reason, common reason, by tangent secant theorem. Okay, now if you observe, I am taking this triangle, I am taking this as point number 1. In triangle PRQ, see, which triangle I am taking? PRQ. Angle PRQ plus angle RPQ plus angle RQP will be equal to 180 degree. Yes, sum of the measures of a triangle. So angle PRQ will be as it is, plus angle RPQ I can replace with angle RSP, and angle RQP I can replace with angle RSQ, equals to 180 degree. This I am writing from 1. Okay, now try to observe this. Angle PRQ plus these two angles, angle RSP plus angle RSQ, this angle plus this angle, I can actually add these two angles, yes or no? RSP plus RSQ will be equal to angle PSQ, equals to 180 degrees. Okay, so angle PRQ plus angle PSQ equals to 180 degrees. Understood? So this is how we have proved this, and the reason we have written this is you can write angle addition axiom. Okay, let us move on to sum number 23rd. As you can see, sum number 23rd, two circles are given, two secants are given, there are three chords, and you can see two cyclic quadrilaterals, RPNM and MSQN. They are two cyclic quadrilaterals. Now this year you have learnt only two properties or two corollary of cyclic quadrilateral. What is the first one? First one is opposite angles of cyclic quadrilateral are supplementary. Okay, now opposite angles are supplementary. So this is the first property. The second property is the exterior angle of cyclic quadrilateral is equal to its interior opposite. Okay, so this will be congruent to this one. Okay, so here also similar case is there where I can write angle MNQ. Angle MNQ is the exterior angle of cyclic quadrilateral RMNP. Okay, MNQ is the exterior angle of cyclic quadrilateral RMNP. So therefore angle MNQ is congruent to angle MRP. Correct? This will be congruent to this one. Okay, and I am giving this as 1. So corollary of cyclic quadrilateral. Okay, then if you observe, this quadrilateral is also cyclic, quadrilateral MSQN is cyclic. Therefore I can write angle MSQ plus angle MNQ equals to 180 degree. Okay, simply I'll write opposite angles of cyclic quadrilateral. Okay, this is point number 2. So if you observe point number 1 and 2, I can replace MNQ with MRP. Correct? So I am writing equation 2 again, angle MSQ plus, instead of MNQ I am writing angle MRP equals to 180 degree. This is from 1 and 2. So if you observe, we have proved this angle plus this angle are supplementary. When you show this a box like shape, they are supplementary. That means the interior angles are supplementary. When interior angles are supplementary means these lines are parallel. Okay, therefore we have reached here. Seg SQ is parallel to seg RP. Reason is very important. Interior angles test for parallel lines. Okay, very easy. Then moving on to 24th one. Coming to sum number 24th, I've already drawn this. Okay, we have to prove that this quadrilateral is cyclic, which is very easy. So I have already drawn what is the construction. Draw AB, AD and AE. Okay, so we'll start. You know, as this question is just similar to 23rd and 22nd one what we did. So angle EBC will be congruent to which angle? Angle EBC will be congruent to angle EAB. Similarly, angle EDC will be congruent to which angle? EDC will be congruent to angle EAD. Okay. Now, EDC will be congruent to EAD. This is what? By tangent secant theorem. Okay, this is point number 1. Okay, now I am taking in triangle BCD, angle BCD plus angle DBC plus angle BDC equals to 180 degree. Sum of the angles of a triangle. Point number 2. See now, angle BCD I am writing as it is. DBC is EBC, one and the same. DBC and EBC are same angles with different name. Okay, so I can replace this with angle EAB, correct? And angle BDC and EDC are same angles with different name. So I'm writing this as EAD equals to 180 degree. Simple. Reason is from 1 and 2. Okay. Now if you observe this, angle BCD plus EAB plus EAD, EAB plus EAD, EAB plus EAD by arc angle addition it will be angle BAD, correct, equals to 180 degree. This is by angle addition axiom. Now if you observe, I have proved the opposite angles of a quadrilateral as supplementary. They are supplementary, so therefore I can write quadrilateral ABCD is cyclic. Reason is very important, that is converse of cyclic quadrilateral theorem. Okay, so let us move on to the last one, sum number 25. So in sum number 25 we are asked to prove that O is the incenter of triangle DEF. Okay, this triangle. So of course we have to first draw seg DE, seg DF and seg EF. Okay, so I'll first draw this. Okay, now when we are asked to show that it is the incenter is the point of concurrence or the point of intersection of angle bisectors. Okay, so simple, I have to show this triangle, these are the angle bisectors. Okay, so first be very much clear what we are going to prove. These are the angle bisectors. only then we can say that O is the incenter. It is already given that O is the orthocenter. Okay, it means it is the point of concurrence of the altitudes of triangle ABC. Okay, now how are we going to prove this? Very simple. First, I'll take angle BFC equals to angle BEC equals to 90 degree. You know, BFC and BEC, they are what? They are 90 degree. Okay, you can see they are on the same side of this segment. Okay, so I can call this as angle subtended by the same arc. Okay, I can write this BFC equals to BEC is equal to 90 degree. This is given. Okay, then points B and C subtend equal angles at two distinct points F and E, which lie on the same side of the line. Okay, they are on the same side of the line, therefore I can write these points automatically become concyclic. Therefore points B, F, E, C are concyclic. Okay, this becomes an arc which subtends the same angle, and this BFEC becomes concyclic points. Okay, therefore I can write angle FEB. As you can see, angle FEB is congruent to angle FCB. FEB is congruent to angle FCB, as they are the points of cyclic quadrilateral. Okay, so I'll write them angles inscribed in same arc. Okay, and I'll give this point number 2. Okay, then you have angle OEC is congruent to angle ODC. OEC is congruent to angle ODC. Okay, equals to, this is 90 degree. Okay, therefore quadrilateral OECD, this quadrilateral is cyclic, because you can see opposite angles are making 180 degree, so it is cyclic quadrilateral by converse of cyclic quadrilateral theorem. Okay, now why are we doing this is angle OED and OCD are congruent. OED and OCD. Angle OED is congruent to angle OCD. Why they are congruent? Because they are inscribed in the same arc. Okay, OED is congruent to OCD. Okay, I can write that as angle OED is congruent to angle FCB. OCD and FCB are the same. OCD and FCB are the same. You can see this FCB. Okay, so OED and FCB. You can write here angles inscribed in same arc. If you see this, I am giving this point number 3, and you observe point number 2 quickly. Point number 2 and point number 3. You can see FCB is common in point number 2 and 3. So what remains? Angle OED. OED will be congruent to FEB. Are you getting? Common part is FCB, so remove that. What remains is, therefore, angle FEB is congruent to angle OED. Does that mean this becomes the angle bisector? FEB and OED means this becomes the angle bisectors. Okay. One, you have proved that FEB is congruent to OED, therefore OE bisects angle FED. Correct? How have we proved? OE bisects angle FED. Okay, so I can write similarly, we can show that OF bisects angle EFT and OD bisects angle FDE. Okay, so this we can write similarly. So I'm writing here, similarly we can show that OF bisects angle EFT and we can show OD bisects angle FDE. Okay, therefore O is the incenter of triangle F or DEF. Understood? Only after writing this you will write similarly, and then you can write therefore O is the incenter of triangle DEF. Okay, this is how you will prove sum number 25, and all the sums we did in this chapter, maybe this one 25th one was little more tricky than the other one, but if you practice it 2 to 3 times it will be far more easier to you. Okay, so ask me the doubts if you have in the comment section below, and keep practicing geometry. Goodbye, good luck.